Good day, everyone. So we have a job to fix here. We have a laptop. This laptop is coming from another computer repair shop. I can't say computer repair shops, but it's coming from another technician who is specializing in cell phone repairs. So according to his explanation, he was using the laptop overnight. He put it on charger. When he tried to power on the laptop the following day, the laptop was dead from that moment. So we have a dead laptop here. This is a Lenovo ThinkPad. Lenovo ThinkPad T45. T450, sorry. That's the model of this laptop. So obviously you open the laptop, but if you don't know what to check, that will not be helpful. So we have customer's charger. There's something which I don't really like about the customer's charger. You see this customer's charger? This tip is not good. It's plugged in already on power source. Let's check the voltage on customer's charger. Ground from this metal. In the plus, we have the inner metal. And the charger is dead. Diode mode. Volts. The charger is dead. That's what I checked when the customer bring in the charger. We checked the charger. I see the charger is dead. Fine. So this charger is not outputting 20 volts, which is the requirement voltage for Lenovo. The next step, what I did, we have the power supply here with Lenovo tip. Let's check this power supply. It's set on 19 volts. So obviously we have 19 here. Let's plug in the power supply. It's taking like one milliamp. Trying to press the power on button here. You can hear the switch clicking. Even with the power supply, this laptop is dead. So it's not the charger. Because even with 19, if you go to 20 volts, 20 points, it's not charging, it's not doing anything. So basically we have a dead laptop here. We have a dead laptop. So let's try to fix this laptop. Let's try to fix it. Let's take out the battery. I need this. There are no screws here because the owner tried to fix it, but probably he didn't see anything there. That's the motherboard. We have a nice motherboard inside here. We have another battery. This model of Lenovo is working with two batteries. We have an external battery. We have another inbuilt battery. Okay. So what can we start to do? Let's take out this main battery, this internal battery. We have the BIOS battery here. Let's reset the BIOS by shorting pins on the BIOS battery connector. Plugging back the CMOS battery. Maybe it's that case where we have to do the basics. Plugging the main battery. I need to plug the CMOS battery also. Maybe it's that moment when you can do the basics and bring back the laptop to life. Plug in the power supply. Still taking 1 amp, 1 milliamp. Hmm? Pressing 0. No. So we have the hard drive here. We have DDR2, DDR3 RAM, network card. So what can be wrong on this one? Huh? Let's start checking some voltages. Where's the power button? Here on this connector. Let's start from the power button going to the motherboard. Let's avoid the charging port. Let's start from the switch connector and check for 3.3. And I can't see any voltage. I can't see any voltage. Okay. Here we have SMAC, that's the EC chip, embedded controller chip. I see startup chip, whatever I call it. We must have 3.3 around this chip from the VREC 3, which is always on. So checking the capacitor around this chip, we don't have 3.3. So the 3.3 is not there. What about 19? What about 19? We have some capacitors here. 0, 0. All the capacitors, they don't have voltage. Huh? Let's check this capacitor under this RAM slot. No. I can't locate the 19 volts. I can't locate the 3.3. This is just a dead laptop. What about on the charging port? The charging port is coming straight here. DC in 0. 20 volts on the charging port. Okay. So the charging port is good. Alright. Let's disconnect the battery. So what can be wrong here? Where are my Mosfets? You see this motherboard. We have so many plastics, so many insulation plastic. I think they use plastics just to insulate the components from the metallic board. You see this board? This back cover is metallic. So if anything happens, without these plastics, bad things can happen. Okay. Let's go under microscope and start to look to check. We want to concentrate on the input section because I suspect there is the problem. I am suspicious about the input MOSFETs. The input section actually. Here. So this is the input section. This is the input section, but I can't see any MOSFET. We have this metallic thing. Shield. Oh, what is that? Huh? What is that here? What happened here? I think the problem is just clear. Huh? Can someone tell me what the problem here? Because here, this is very clear and straightforward. We have the charging port, that's the plus, and the plus we have two tracks here, which is going to this fuse. I don't know what happened here. And those Mosfets, they insulate with this chemical, which I don't know what the chemical, but I don't care. What I care, do you have a shorted parallel? Let's go on the current sensor. Current sensor to ground, we don't have short. But how am I going to check those Mosfets? Huh? With this metal thing. Fuse. We have a fuse here. A fuse should be beep. We hear the beep. This fuse must be beeping, and it's not beeping. So, yeah, that is my first problem. Let's check out that fuse. Let's check out that fuse before we go anywhere. I don't really understand what happened here. On Lenovo, most of Lenovo motherboards, they put a fuse on the input section. In case of anything happen, the fuse will blow up. Just to protect the circuit. So, you understand? But that fuse blown up for some reasons. But I want to put another fuse there. I want to put another fuse there. This time, I won't use a wire. I want to do it the proper way. I'm not using a wire this time. Here's our fuse. Our fuse is now in place. And I believe that fuse must be a working fuse. We must hear the beep because the multimeter is not on the screen, but we must hear the beep. You can hear the beep. We have a good fuse. And current sensor to ground, any short. It's not shorted. So what are the odds just to have a faulty fuse here? Okay, let's put back this shield, because they put the shield there for a reason. They put this shield for a reason. Uh, what are the odds here to have a working laptop? I never found like a blown up fuse only. But what I want to do, uh, I want to check the capacitors around the EC chip. Okay. What about those capacitors? These capacitors which are beeping, this is the processor power supply. So if we check capacitors on the processor power supply, which is meant to work with 1 volts or 0.9, actually what is beeping here is not the shorted capacitor. This is the resistance of the processor. So I will ignore those capacitors. What I want to do is that good moment to see what's going on here. Maybe that was just a fuse. Who knows? Maybe that was just a fuse. 2 milliamps. 1, 2. There's slight change in current, in standby current. Power on. On. No. It's not working. But it's good. It's good because we have a starting point. It's good. Volts. On the current sensor, we have 0 point. Still, we don't have voltage on the current sensor. Okay. I thought that was a fuse. Huh? I thought that was just an ease to replace a fuse and we have a working laptop. Huh? It doesn't work that way. Oh, it doesn't work that way. So let's pay attention here to those Mosfets. I think something's not right here. Let's check out this. Whatever was used to insulate here. Huh? We want to reach the pins of the MOSFET so that we can properly test what's going on exactly. Good. Now let's test. Because we don't have shorted output, so okay. So why? 1 second. Why it is like this? What I want to check, voltage on the gate. Okay. Volts on the gate. We have 20 volts exactly on the gate. Okay. So if you have time, you can spend much time trying to analyze about the BQ chip and everything, but I don't have that time. So it's that moment to do the Dodge style. Let's check out this MOSFET exactly here. Good. Bypassing MOSFET. Yes, we can. We can do that. We can do that. We can do that just to understand the kind of fault that we have. Uh, so, like what I said, if you have time, you can check why the first MOSFET is not outputting anything. But from what I see, the MOSFET is just lazy to drive 19 volts. It's tired of holding too much currents and voltages. Because if we check the second MOSFET is good, we can check again. Drain to source, good. And then source to gate, no, here. Source to gate is not beeping. So that's the story. If you really want to do a research why that MOSFET is misbehaving, you can go ahead and do that. it is allowed to spend much time, but myself 300 and the laptop just started. You can see that current. You see the light here. Now it's taking 2 amp and we have Lenovo. Ah, it's working. Huh? It's working. Escape. The laptop is working and it's off. Yeah, because we reset the BIOS. So we must expect coming on and goes off. It's trying to reload the settings. And it's taking 1 amp. That means it's charging fine. Escape. Huh? Check on the screen. It's taking 2 amps and it's loading Windows. Huh? It's loading Windows. So even without that MOSFET, the laptop will still work fine. The laptop will still work fine. And the laptop is on. As you can see, there's no user password there. Let's check the battery percentage. It's at 6%. As you can see, 6%. Let's just wait and check again. Let's see now. Let's see now. What this is 5 minutes after plugging on power supply. Let's check what voltage do we have now. It's now at 12%. From 6%, we now have 12%. So it's charging fine without that MOSFET. You understand? Because what those MOSFETs they are doing, they are switching devices. In case of any short of anything, they are cutting down the power. So I was lucky. I was happy that it's only the fuse, but that wasn't a fuse. Then the second MOSFET is not shorted. I'm sure maybe something's wrong with the BQ chip. Why the first MOSFET is not passing? But I don't have time. If there's another way to solve the problem, I think that would be great like this. I don't hesitate to give the customer warranty because the job is done. Now, the laptop is fixed. We agree that the laptop is fixed no matter the how part. So what I want to do, let's switch it off completely. The laptop is now off. Let's concentrate on the customer's charger. Why we don't have voltage there? Huh? Is it because of this or because of something else? Let's just help the customer. I didn't charge him for this, but just to prevent coming back jobs, because obvious this can be the reason why that fuse is blown up. Maybe the plus and minus shorted together and burn up the fuse. But this is a luck customer because in most cases, if the plus and minus, if you short the plus with the middle pin, you burn the startup chip. In most of the Lenovo laptops. So I can say this is a lucky customer. This is just a luck customer. So now I want to plug in and see if it's reaching this end. The 20 volts is reaching that end. Maybe if it's reaching that end, we can help the customer. Volts. And the charger is dead. It's just a dirty power pack. Okay. Can we fix the power pack? No. I think what I would do, yeah, we can fix this, but we have to talk with customer because it's about time. It's about time fixing this power pack, or it's more easy just to buy another one. So the idea of this video, or I will even give the customer another power pack. The idea of this video is about how you can fix a dead laptop motherboard. The diagnosis procedure from when the laptop is off. We started from the power on button going to the 3.3 to the 19, going backwards, and we managed to fix this laptop. So like, subscribe, don't forget to turn on the notification bell for future updates, and see you on the next one. Bye.